Hey Algebra 1. Today in lesson 21, we're going to be graphing linear inequalities in two variables. So far, we've graphed inequalities in one variable. So if we're graphing something on a number line, like x is less than or equal to 3, we know that x could be 3, but it could also be any of these numbers that are less than 3. So when we're graphing an inequality in two variables, it will be something more like we have a whole line on our graph, and we're talking about whether our inequality is greater than that line or less than that line. So first, we are going to test some points in this expression, 2x plus 3y, and decide if the values make the expression less than, greater than, or equal to 12. So our expression is 2x plus 3y. The first point I'm testing is 0, 5, which means my x value is 0, my y value is 5. I know 2 times 0 is 0, 3 times 5 is 15, and 0 plus 15 is 15. The question is that less than, greater than, or equal to 12? This one is greater than 12. Okay, do the same thing for the next two. Nope, next three. There are three more. Check if these values for x and y make the expression less than, greater than, or equal to 12. Pause the video, actually do the math, and then come back and check your work. Okay, so hopefully you actually paused and did these problems on your own. For the second one with 6, 0, we plug in x and y, calculate, we end up with equal to for that one. For -1, -1, plug in your values for x and y, calculate, this one ends up being less than, and the last one with -5, 10, plug in x and y, calculate, we end up with 20 is greater than 12 for that one. So when we're graphing an inequality, we are going to be looking to figure out which side of that graph follows the inequality that we're given. So we start out just like we're going to graph an equation. The first step is to use the slope and the y-intercept to plot the points that make up our line. So in my first problem, I have y is less than 1/2 x minus 4. I know I start this graph at -4. That's my y-intercept. So my first point goes here. My slope is 1/2. So that says I'm going to rise 1 and run 2. And I'm going to keep doing that until I run out of space. When I run out of space, I go back to my starting point. And now I'm going down 1 and left 2 until I run out of space again. Normally, we would draw a line here, right? Like we'd be done. This would be the whole thing. But if we're graphing an inequality, sometimes our solution is not equal to the points on the line. So sometimes we'll have to use a dashed line instead of a solid line. The way to figure out if we have a dashed line instead of a solid line, if you think about would it be an open circle or a closed circle on a number line, it's the same deal for a dashed line or a solid line. So if you have less than or equal to or greater than or equal to, that would be a solid line. If we have just less than or greater than, the line on your graph will be a dashed line. So for this one, my inequality symbol says that y is less than 1/2 x minus 4. That tells me it's not equal to 1/2 x minus 4. So this is going to be a dashed line. So we're just going to fill in the spaces between the points on our graph. So now one side of this graph is going to get shaded. we're going to shade the side that shows all of the values where y would be less than 1/2 x minus 4. So in those first problems up above, we were testing some points to see if they would be less than, greater than, or equal to. We're going to do the same thing here. We are going to choose a point to test. And I like to choose a point that's as easy as possible. My favorite point to choose is 0, 0. I am going to check if 0, 0 is a solution to this inequality. So if I plug in 0 where x is, and I plug in 0 where y is, do I get a true statement or a false statement? In this case, let's see, we've got 0 is less than 1/2 times 0 is 0. 0 minus 4 is negative 4. So is this a true statement? Is 0 less than negative 4? No, that's absolutely not true. This point is not a solution to my inequality. If we check another point, I'm going to try one on the other side of the line. Let's try what's going to be a good one? Let's try 5, negative 5, this point right here. If I check 5, negative 5, my y value is negative 5, my x value is 5. Is this a solution? Let's see, 1/2 times 5 would be 2.5. And 2.5 minus 4 would be negative 1.5. Is negative 5 less than negative 1.5? Yeah, it absolutely is. So this point right here is a solution to the inequality. If I checked any of the other points down here on this side of our line, all of these points would be solutions. If I kept checking points on the other side of the line, all of these points would not be solutions. They would not make that inequality true. So to show that all of those blue points are part of the solution, we shade this side of the graph to say all of our solutions, any point down here is a solution to that inequality. We're going to do one more together where we do the whole full thing. And then we're just going to practice the testing points part. So for the next one, the first step is to graph the line. But right now, this equation or this inequality is not set up to be graphed. It doesn't have y by itself. So before I can do anything else, I've got to do some work here. Oh, I'm going to run out of space. Okay, before we can do anything else, we need to get this equation in slope-intercept form. So I need to get y by itself, so I subtract x from both sides. I know I can't actually subtract x from 10, so I just write it as 10 minus x. And then to put this in slope-intercept form, I just need to flip those. So I get y is greater than negative x plus 10. So when I start graphing this one, my y-intercept is at positive 10. My slope is negative x, so I'm going down 1 to the right 1 until I run out of space. Once I run out of space, I'm checking, is this a dashed line or a solid line? In this case, we're going to have a dashed line again, because our inequality symbol is just less than. It's not less than or equal to. Okay, so once we have our line on the graph, we need to figure out which side of this graph should get shaded in. So I'm going to choose a point to test. I'm going to choose my favorite point. My favorite point to test is 0, 0. I am checking if I plug in 0 for x and 0 for y, is this a true statement or a false statement? So my inequality said x plus y is greater than 10. I plug in my zeros. Is 0 greater than 10? No, absolutely not. That is not a solution to my inequality. I could keep checking points to see which part of the graph will have solutions, but really, if I know that 0, 0 is not a solution, that tells me that the other side of this line is where the solutions happen. So I can shade that part of the graph. So the line is kind of our boundary. It divides the graph into two parts, the part that is the solution and the part that's not. Always go back to your 3 steps that are here. If you follow these 3 steps and follow your examples, you can graph inequalities. So on the next page, they have graphed the equation x minus y equals 5. That's this equation right here on the graph. Your job is to sketch 4 quick graphs representing the solution to each of these inequalities. So part of these are all the same. They all have x minus y. They all have 5. What's different about them is the inequality symbols. So the line's not going to change. All of those points on the line are going to stay the same. What will change every time is if it should be a solid line or a dashed line, and which side of that graph you're shading in. So the first thing you want to do is decide solid line or dashed line. If we look at the first one, it says x minus y is less than 5. That tells me this is going to be a dashed line. So the whole thing isn't solid. This is a dashed line. Now I need to figure out which side of this graph should I be shading in. I'm going to check my favorite point. I'm going to check 0, 0. When I substitute 0 for x and for y in this inequality, I get 0 minus 0 is less than 5. So 0 is less than 5. That is absolutely a true statement. 0, 0 is a solution to my inequality. So I'm shading the side of the graph that has 0, 0 in it. Pause the video. Go through the other 3 graphs here. Think about if you should have a solid line or a dashed line. Test a point to figure out which side of that graph to color in. All right, for these last 3 graphs, top right graph, you should have a solid line because it's less than or equal to. And depending on what point you checked, well, no matter what point you checked, you should be shading above the line, the part that I've got shaded in there. Bottom left, this one is a dashed line. And for this one, 0, 0 is not a solution, so we're shading below the line there. And for the very last one, this one is a solid line because it's greater than or equal to. 0, 0 is not a solution, so we end up shading below the line. So when you're doing these problems, the very last part of this before we're done is about looking at a graph and writing the inequality that it represents. So when we look at this first graph, this is a vertical line. It goes through the x-axis at 3. So anytime you have a vertical line, the equation just has an x in it because it's only going through the x-axis. If I look at my inequality, this is a dashed line, so I know it's either going to be less than or greater than. There won't be an or equal to here because it's not a solid line. So now if I try and decide, is this less than or greater than? Well, the side that's colored in, these are all numbers that are greater than 3. So I know my inequality symbol here should be greater than. If we look at B, this one is a horizontal line. This horizontal line goes through the y-axis at -2. When we look at our line, it's a solid line, so I know I either have less than or equal to or greater than or equal to. And if I look at all these y values that are shaded in are numbers that are less than or equal to -2. Right, down below we have some diagonal lines. If I had to write the equation for this line, I'm looking for an equation in slope-intercept form. So I need to know the y-intercept and I need to know the slope. For this graph, my y-intercept is 0. And to get to the next point on the line, I have to go up 1 and over 1. So I know my y-intercept is 0. I know my slope is 1. So this equation would look like y equals 1x plus 0. But this isn't an equation, it's an inequality. So I need to figure out which symbol belongs here. I know it's either going to be less than or greater than, because it's a dashed line, it's not a solid line. So now if I think about this, all of these points up here, these points are all points that are above the line. If we think about numbers that are above, those numbers would be greater than. Our last one has the same equation as before, the same slope, the same y-intercept. The part that's different is the part of the graph that's shaded in. So because this is an inequality, I know it's not going to be equal to. This time we have a solid line, so it's either less than or equal to or greater than or equal to. If I look at the part of the graph that is shaded, it is the part that is below the line. When I think below the line, I'm going to think less than or equal to. Great, there is a summary that you can read that just has more examples on the last page, but that's the end of lesson 21.